Hello and welcome to Perth South. Last time I looked at Perth station area and aspects of it that I'd like to include in the model. This time I'll explain the plan of the layout and the approach to construction. I'm a returnee to the hobby after many years away and was keen to catch up on all the latest thinking, equipment and tools available. One new tool for me was layout design software, and after looking at a few different products, I decided on AnyRail to plan the layout, and this proved to be a really good decision. I had a loft room available, some 6.1 metres by 3.7 metres. So the starting point was to have the shape of this room on AnyRail, showing the access hatch, boiler room door, and side hatches and windows, as all of these would have a bearing in the plan. The grid in the diagram is 1 foot by 1 foot squares, which is the usual for double O gauge. However, with hindsight, I would have been better making these a round metric number, as I do tend to do all my other measurements in metric. The station layout was created first, largely following OS map track layouts, backed up by a copy of the 1962 re-signalling plan. This re-signalling plan has been very useful in the planning of the layout. Again, most of the mainline signalling and track layout that you see here still exists to the present day, although obviously the connections into the loco depot here. Note the comments here for ingoing engines and outgoing engines. All of these connections were removed just after the depot was closed, and the down goods loop's gone now as well. So here's my version of the station. All of the platforms are there, as is the old centre track and the Dundee platforms. The carriage sidings are represented next to platform 7. And at the left hand, or the north end of the layout, a scenic break allows the platform tracks to curve round and head towards the hidden sidings, which are under the upper level. Similarly, the Dundee tracks descend downwards towards the hidden sidings. The next part of the layout is south of St Leonard's Bridge are the various loops and main lines. These in reality are dead straight in a north-south direction, but for the purposes of the layout they have to be in a curve, taking them through 180 degrees. It looks like a lot of track, but it is fairly close to prototype. I have, next to the up and down main lines, I have a down slow representing the slow lines that used to go right round the west side of the station. On the other side of the main lines I have the down and up Dundee loops, exactly as per prototype and as still exists today. And next to these two other loops, these were originally carriage sidings, but I'm using these as goods reception and departure lines. I've included a goods yard instead of the wagon repair workshops that were here in the original. Next, heading south and round to the other side of the layout, is the Edinburgh Road Bridge, and beyond that, of course, the Locomotive depot. Unfortunately, Perth 63A MPD is just too large to get it all in a model form, so some modeller's license has had to be employed. I was keen to try and keep the general depot layout with its design for ingoing and outgoing engines and the relative positions of the turntable and the coaling plant. But after considering many different options, I've moved the turntable to the north of the Edinburgh Road Bridge. The running shed is reduced to 6 roads instead of 8, and the depot offices and the heavy repair shed will be represented in the back scene. However, the distinctive design of the running shed and the coaling plant and ash facilities, all of which I'll have to scratch build, I hope will still be recognisable as Perth MPD. Continuing south, we have some main lines that will go into Moncrieff Tunnel. The north and south approach lines pass each other and head downwards towards the hidden storage sidings. The southbound tracks pass behind the station and downwards until they can pass under the scenic area. Similarly, the northbound tracks head down, round and under the area of the Loco depot, as do the Dundee lines. This view shows the lower level hidden sidings and reverse loops. The design allows trains leaving the station, both north and southbound, to return in the opposite direction later in the operating sequence. Northbound trains pass through the hidden sidings, go round the north reverse loop so that they can return again southbound. Similarly, the southbound trains can travel round the south reverse loop and head northwards again. This view shows both the upper and lower levels together and shows the complexity of trying to avoid clashes with baseboard framing, point motors, etc. Luckily, AnyRail calculates gradients and spot heights, allowing you to check for clearances between overlapping tracks. The MPD area has had to be raised slightly to provide clearance for the Dundee tracks and means additional gradients in other parts of the layout. With a multi-level track layout, I used the L-girder approach to baseboard construction as it's ideal for adjusting track heights and gradients. Again, the layering function in AnyRail was great at allowing me to plan the different parts of the baseboard framing. Pink represents the main L-girders and associated base level joists and edge framing. Blue is the upper level track bed support framework, and yellow the risers. Track bed edging is shown in green. L girders were made up from 4 inch by 1 inch and 2 inch by 1 inch timbers combined, and the joists, risers and cleats all made from 2 by 1 timber. Track bed is 9mm ply. One of the mistakes I've made is not using the best quality plywood. It seemed okay at first, but I've had problems with poor quality laminations and gluing in the ply. Most problems have been sorted by additional bracing or supports, but I do hope I don't have long-term problems with this. I've also been disappointed with the quality of the 2 by 1 timber and have had some wastage due to warping. Luckily, the 4 by 1 timbers that make up the L girder have been fairly good and true, and this is what provides the base level for the layout. Other timber problems can be dealt with by adjusting the cleats or risers to get the track to the correct height. Support legs are 2 inch by 2 inch timbers with an adjustable screw in the ends to adjust the height. I had to take great care when designing the individual baseboards to make sure that I'd be able to lift them and get them through the loft hatch, as they were cut and assembled in my garage. I also wanted them not to be portable but dismantleable should I need to remove it from the loft at some stage in the future. Also important was to design them so that board joints were in suitable locations in the track plan, avoiding sets of points, passing across joints and joists missing position of point motors. This resulted in 18 separate baseboards bolted together. A difficulty with this type of baseboard style is transferring the track plan to the track base plywood and getting the curves and point positions correct in the plywood. Again, any rail helped here by having a facility to transfer the track plan to a full-size PDF file, which I got printed out on A1 sheets at a local printer. I used a small scale plan to cut out the track bed shapes to work out the most efficient use of plywood. This still ended up using 10 8x4 sheets to provide all the track beds as well as backboards for electronics, etc. The full-size track plans were then pinned down on the 8x4 sheets of plywood in the appropriate location, making sure adjoining sheets were lined up, and the track plan and track bed boundaries traced through onto the plywood, which could then be cut out with a jigsaw and positioned on the baseboard framework. Having lots of model trains running at once creates a lot of noise, especially in a loft room with a plywood baseboard. So I used DCC Concepts foam underlay as a track base rather than cork. Again, I've used DCC Concepts power base on gradients. I've tried to keep gradients to less than 1 in 40, but it's 1 in 30 in the D lines, and I reckoned better putting it in with the track now, and then I have the ability of adding magnets to the engines that struggle in the gradients. Track is Pico Streamline Live Frogs, code 75 for the scenic area, and code 100 in the hidden sidings. I learned when I was modelling first time round in the 60s and 70s the inherent unreliability of dead frogs, and I would never use them now. All points are wired in the usual way for DCC, with point blades and stock rails bonded together and frogs, or crossings, powered through a switch on the point motor. Anyway, that's all for now. Next time I'll spend time explaining my approach to operation and control. Many thanks for watching and hope to see you soon.